The purpose of this video is to show two sample comparisons, and what we're going to have a look at is firstly how salary is associated with sex, male or female, so who's getting paid more, men or women. And then we'll look at a categorical outcome variable, which will be voluntary turnover in this spreadsheet, which is either yes or no, no coded as 0 and yes coded as 1. And we'll see how that varies over the levels of gender. So we're going to do two sample comparisons for population means. That's when we have a look at the salary variable as the outcome, and then we'll do two sample comparisons for a population proportion for population proportions. That's when we look at voluntary turnover. So let's just get started. First of all, we'll check out the gender variable, male and female. We can see that in the data set that I'm using, the human resources data set, we've got about 3,100 males, 2,500 females. You don't need to have the same number of men as you do women. You do not require balance for these procedures. We should also have a look at the outcome variable salary just to get a sense of what that looks like too. So there's the salary distribution, no crazy observations there, nothing above 150,000, nothing below 18,000. So it's sort of low to mid-level employees in this data set. So what we want to do now is see whether or not there's some difference in the average salary across men and women. And remember, we are working under the premise that these are samples from some underlying population, that these are both random samples. So the dialog that we use for these two sample comparisons is analyze fit y by x. And salary is going to go in as the y, the outcome variable, and the x variable here is gender. Now note that it is a categorical variable, and we know that it's actually two levels, male and female, and the red bar chart there is indicating to jump that this is a categorical. By having a categorical x and a continuous or numerical y variable, the appropriate analysis is going to be offered to us. So now we click on OK. So we get a graph that shows us not too much at this point, but these are the salaries of the women and the men. If I right click on the title bar, I can add the quantiles there, and then I start to get a sense of what's going on. I can see that the median for women is about 52,000 and men 56,000. So it looks like men may be getting paid a little bit more than women, but we always have to make a call as to whether or not we think the differences we're seeing are statistically significant or possibly just chance variation. So the way that we're going to approach this is to do a two-sample t-test. Now, I'm going to have a look at the means just to get started. So I'll right-click on the title bar and say means and standard deviations. And now I can see the mean salaries here. 57.3 thousand for females, 58.6 thousand for males. So there's about $1,300 difference in salaries on average between men and women, between the sample means. Now, in order to do the two sample t-test, I go up to the title bar, I right click on it, and then I just choose t-test. And when I do that, I get the t-test output down at the bottom, so we'll focus on the output. So just to be clear, it's this output that I'm highlighting there. And what we see is, first of all, the difference here, $1,314. That's the difference between males and female salaries on average. The standard error has been calculated, 580, and here's the 95% confidence interval by default. It's from about $175 to $2,450. So that's the range that has, with 95% confidence, covers the true population difference in mean. So that's a confidence interval for what we'd usually call mu1 minus mu2. So we have a sense that the difference in underlying means is anywhere between about $175 and $2,452. Look at the confidence interval here and notice that 0 is not in the interval. That means that 0 is not a feasible value for the difference in population means. And so if the difference isn't 0, well, then there is some difference between them. In fact, we estimate it at about $1,300. So the fact that 0 isn't in this interval gives us statistical evidence that there is a significant difference between the two means. You could equivalently go over here and look at the t-ratio, which is 2.26, and that tells you that the observed difference in sample means we have, about $1,300, is a 2.26 standard error event. So under the null hypothesis, which is that the population means are the same, we have just observed a 2.26 standard error event. Now that's unusual by our typical reckoning of being greater than +2 standard errors or less than -2 standard errors. So it's outside the plus or minus 2 cutoffs, and so again from the t ratio we have evidence against the null. Or you can have a look at the p-value, and here I'm implicitly doing a two-sided alternative, so I'm going to look at the two-sided p-value, the one that is prob greater than mod t to denote two sides. We're interested in men getting paid more than women, or women potentially getting paid more than men. And there's the p-value 0.0237, and our rule on the p-value is that if the p-value is less than 0.05, then we're going to reject the null hypothesis, and which is what we'll do here. So we have some evidence of a difference in salaries between men and women, and that difference is statistically significant using a level of statistical significance of 0.05.